this is the question I got asked, okay? And some people are scratching their heads over it, which is fair enough because it doesn't quite match up with the questions the limits that I showed you before, okay? The ones we're thinking of are, that we proved are x on sine x on tan x, and their reciprocals. We showed they're approaching 1, no problems, okay? And this guy kind of defies that because, well, you definitely don't have tans. And we have sines, but you've got an identity happening down there which is going to eliminate your sine, right? So the question is, if it's not going to be one of these identities, which one should we use? So first, let's see what we can do with this. Now 1 minus sine squared, when you see that, what's the first thing your brain does? Cos squared, good. So you've got the limit as theta approaches 0 of theta squared on cos squared, okay? All right, now the first thing I'm going to say after that is that if I've got a square on the top and a square on the bottom, I can consider the fraction, and then I want to consider that as squared. So if I can work out what that's doing, right, then I'll work out what's the whole thing is doing, okay, depending on what it's equal to. Now, theta, as that approaches 0, theta becomes 0. That's okay, it's just theta on the top. Now what's happening to cos theta? Well, hold on. We know what happens to cos theta. There's cos theta. Right, now the reason why I've drawn it negative and positive is so that you can see whether you approach it from this side, which by the way is written like this, theta approaches 0 from the positive side, or whether you approach it from this side, which is the limit as theta approaches 0 from the negative side. You're like, there's negative 0 and positive 0? When there are limits, there are. What's happening? Well, they're both approaching the same value, namely 1, right? So therefore, if I can actually evaluate this limit, having cos theta on the denominator is not a problem for me, okay? So this is 0 over 1 squared, which I hope is 0. Check my arithmetic. I think we're okay. So even though it doesn't fit into one of these, it ought to be a limit we can evaluate. Remember, if I can get it into a shape where I can simply actually substitute theta in, then it's fine. Now, just to give you an example of where this is a similar kind of things happening. Do you remember when we were differentiating the square root of x? Do you remember doing this one from first principles? Does it vaguely ring a bell? Yeah, okay. Now, no, okay. What you're going to get is the limit as h approaches 0 of this guy. Okay? And the solution to this doesn't actually completely cancel out the denominator. You still get something on the bottom. But the point is that what you end up getting, you can actually evaluate at h equals 0, just like you could evaluate this at theta equals 0. Okay? So in terms of evaluating limits, you've got these kinds of strategies of get it into some kind of limit that I recognize, which I had to prove, but now I know they both approach 1. Okay? Or alternatively, just get it into some kind of shape using identities that you know, so you can just stick in theta equals 0 and it will work out. Does that answer your question? You'll get lots of those kinds of variations. The reason being that there's only so many questions you can write using those identities, and maths teachers get bored. So they're like, how can we shake this up a little bit? So, okay.